This video tutorial presents a generic experimental procedure. Please consult your class notes for term-specific instructions. The lab has two Instron testers with a central computer console to interface with both machines. For this aluminum tensile test, we'll be using the 5984 on the right. Press button number 2 on the KVM switch and then turn on the right computer. To power up the Instron, toggle the switch located at the base on the right side. Wait a few minutes for the Instron to initialize as indicated by the red LED denoted Frame Standby. Launch the Instron Blue Hill software using the shortcut on the desktop. Once the Blue Hill software has fully loaded, the green Frame Ready status LED should be active. Use the jog up-down buttons for coarse adjustment of the crosshead. The thumb wheel is for fine adjustment. Position the crosshead to accommodate a dog bone specimen in the grips. Press the GL reset button to zero the current position. Click the frame icon located in the upper right. Select the load icon from the transducer status bar. In the pop-up window, verify the 150 kilonewton load cell is the selected transducer, then click on the Calibrate button. A warning prompt will appear to verify the grip is unloaded. When ready, click the OK button to proceed with calibration. After calibration has been completed, press the Balance button to zero the load measurement. Click the Close button to exit load cell calibration. Install the calibration pin in the extensometer to set the gauge length to 25 millimeters. In Blue Hill, click on the Strain 1 icon, which opens the calibration window. Verify Strain 1 is the selected transducer, then click the Calibrate button. A warning prompt will appear to verify the extensometer is at gauge length. Click OK to proceed with the calibration. Afterward, click the Balance button to zero the gauge. Then click Close to exit calibration. Finally, click the Close button to return to the home screen. Each lab section is provided with an aluminum dog bone specimen. Measure the width, thickness, gauge length, and overall length of the specimen using a digital caliper and/or micrometer. For replication, have several students measure the specimen and record them in Google and/or on the front board to share with the entire lab section. Install the aluminum dog bone into the grips and tighten until firmly snug. Be careful not to over-tighten, which may damage the grips. Next, gently install the extensometer near the midpoint of the specimen. Once seated, carefully remove the calibration pin and allow it to hang. When done, close the guard door. In Blue Hill, click on the test icon, which opens a window of available tests. Select the aluminum tensile extensometer test method. The next window configures the travel limits. Ignore this screen and click OK when presented. Once the test method is loaded, you'll be prompted to enter the term, section number, and file name. Use a unique name identifying the term and lab section. Click the Next Before Test button when ready. Enter the width and thickness using the average of the student's measurements. Press the Start button to initiate testing. The tensile load should gradually increase. Initially, the dog bone experiences elastic deformation. At the yield point, the specimen transitions into the plastic region, i.e. permanent deformation, as indicated by the change in the slope of the curve. At 10% strain, the test is paused and a prompt is displayed to remove the extensometer. Open the guard door and gently remove the extensometer and set aside. Then close the guard door. In Blue Hill, click the Resume button to continue the test. Strain is now extrapolated from the previous strain-displacement relationship. Upon fracture, click on the Next/Calculating button. Then press the Finish icon, which looks like a checkered flag. When prompted to start another test, select No. Remove the test specimen from the grips and press the Return button to return the crosshead to the start position for the next lab section. From the Methods window, select the Home button to return to the main page. Then, click the Exit icon to end the program. As a sanity check, piece together the fractured specimen and approximately measure the gauge length. Use this measurement to compare the overall strain with the measured value. Here's a sample data file opened in Excel. The sampling rate is set at 5 Hz with all the time-dependent values listed in columns. The column titled Strain contains the extensometer measurements until the extensometer is removed. The adjacent column, labeled Tensile Strain, contains the calculated strain by establishing a relationship between displacement and strain, which is valid up until fracture. The test data should be uploaded to Canvas to be shared with the entire lab section and others. Be sure to save the data before you leave the lab today.